Hiva Paiva. Well, that's the way we say hello in Finland. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics, wherein today we are going to discuss divisibility by binomial theorem. Here we will be discussing what binomial theorem is, when is it that it is significant, and how to find out the sums on divisibility using binomial theorem, although they can be done by other methods also. So now children, all of this and much more, as there'll be a second explanation and there'll be more sums in the series of these sums on binomial theorem, which I will give you a link to follow where you can look it all up. Now, before I get started, I'll quickly like to tell you about this paradise location which you're getting to see. This is a place that I chose when I went to it. It is Järvi-Suomi, Lakeland District, Finland. Now, this is an awesome place which was made from the times of ice ages 10,000 years back, and it has been shaped by the ice ages. So there are many interesting facts about this place, but we'll be discussing that a little later in the lecture. First, let's get started and let's do a little bit of studies. Then when it becomes a little overwhelming, then we'll be doing some humor. I'll be telling you some awesome facts about this land, and then further we'll be looking up the sum and ensure that when you people are hungry, I will also serve you people with some nice sweet delicacy of this place which will satisfy your hunger. So children, before we get started, I would like to start this lecture in a humorous note. That is, when we talk about this place, Finland, it has some of its special characteristics jokes. Now, can anybody tell me where will you normally find a person from Finland? I'm sure most of you people are telling me that they will be found in Finland. No, they will be found in sauna baths. Do you know what sauna baths are? These are those places where through dry heat, the temperature approximately reaches as that of boiling point of water, and with that there is a lot of relaxation and spa activities which can be done. And I'm sure you'll be astonished to know, so why will a person from Finland be found in a sauna? That's because in Finland there are 3 million sauna baths for a population of just 5 million. Right? So that's pretty astonishing, and this is actually the joke. I'm sure this made you smile, right? Okay. Now children, let's quickly get to this topic of binomial theorem, and let me quickly explain to you a thing before asking you people a question. Don't mind, I have this habit of asking you people questions to check whether you know something or not, to access your attention and also to increase your intellectual capacity so that you can think along the way. Now children, just tell me, if you talk about, say, something like a plus b whole square, right, what is it going to be? You've studied this in algebraic expressions, and I'm sure you know this, that this is an algebraic identity which is given by a square plus b square plus 2ab. And I'm sure you people must be thinking, why am I telling you this? Now, without telling you that, I'll rather ask you another question. What is a plus b cube? Now, I'm sure you must be thinking that I'm probably taking your test. No. There is something which is ironic, which is going to come next. Now, when we talk about this, this is another algebraic identity that you studied, and it is equal to a cube plus b cube plus 3ab times of a plus b, which when expanded gives you a cube plus b cube plus 3a square b plus 3ab square, right? Now children, up to here everybody knows, right? If they've done their class 8, class 9 properly, everybody knows that a plus b whole square is this, a plus b whole cube is this. Now what about if you are asked some a plus b raised to the power 6? Will you be able to tell out the value of this? I'm sure there are some smart children here who will tell me this, that sir, this can be written as a plus b, which is raised to the power 3, and then we can square it. Or we can even say that that is a plus b, which is whole raised to the power 2, which can be cubed. No, it is not this that I'm telling you. So what then about a plus b raised to the power 16? So if say I am interested about some power of a plus b, which you normally don't know, like suppose 16, 17, anything, I'm sure you will not be able to give an answer directly. Now, to be able to give an answer directly is why we study binomial theorem. That is, we want to expand a binomial generally so that you can get to what will it exactly be when it is any integral power of a binomial. Normally we keep a positive integer, but if suppose it's a negative integer, no problem, that term will go over to the denominator, because I'm sure you people know this, that if we talk about a raised to the power minus m, then that becomes equal to 1 upon a raised to the power m. So then too, the same procedure is going to be followed, right? So let us now try and answer this inquisitive question, that if we have some crude positive integral power which is in the index of a binomial, how do we exactly expand it? So for that, now we have this. This is a formula. This is the format which is that of a binomial theorem, and at this time I like you people to fully focus here. For that matter, whenever I'm teaching you people, I like you people to be sitting straight with your spine straight, right, at a place which is secluded so that there is no disturbance. Make sure that you're sitting on a table and chair and you focus exactly where I am. So if I am at O, you have to be at O. If I am at E, you have to be at E, and so on. And that will ensure that the understanding is really resounding. Okay, so getting back to what binomial theorem is, if you have say some x plus a, which is normally the conventional binomial which is taken, and if it is raised to n, and now here you know that n is a positive integer like 7, 17, 23, anything. Okay, so we write it to be nc0, where this is a binomial coefficient, times of x, which is raised to the power difference of the numbers in the superfix and the suffix, that is n minus 0, times of the second term a, which is raised to the power number in the suffix, that is 0, to which is added nc1 times of x raised to the power n minus 1 times of a raised to the power 1. Here, if you see that this is again the difference of the numbers in the superfix and the suffix, and the index of the second term a is again the number which is there in the suffix. Now I'm sure with me you people will be able to tell, or rather I'll be silent, you tell me, I'll be writing, you check it out, whether now you're going to tell me the third term correctly or not. So I'm writing silently, you tell it. Right, I'm sure you people must have told this, that it is nc2, right, because after nc0, nc1, the next binomial coefficient is going to be nc2. Don't be worried about what this is. In times to come, just now I'll be describing it all so that there is no confusion about the binomial coefficients. Now then, this is to be multiplied with the first term x, which is raised to the power difference of the numbers in the superfix and the suffix, that is n minus 2, times of a, the second term, which is raised to the power number in the suffix, right? So all of this, children, continues, right? And then in between we get the general term, which is written like ncr. Again, the power of x will be the difference of the numbers in the superfix and the suffix, that is n minus r, times of a, the second term, raised to the power number in the suffix, that is r, right? So this, children, is the general term. This is something that you should remember, because in times to come there are questions in finding out the general term, or probably a specific term which can be found out from the general term. Like suppose if you're asked the 10th term, if you're asked the 13th term, so obviously this is going to become a formula, right? So then after this, children, we now talk about this continuing up to the last term, which is ncn x raised to the power, again the difference of the numbers in the superfix and the suffix, that will make it 0 times of a the second term raised to the power number in the suffix, that is n. So this, children, is the expansion of any binomial. So if you talk about the value of n to be 13 or say 23, I'm sure using this you will be able to write the exact value of the expansion within not having to think much as to how you got to find out, that means with what you got to multiply what, so as to get to it, right? Okay, now children, I will quickly discuss this once more, what all I said, and after that we will come over to the binomial coefficients and the different terms, right? So if say we now talk about a binomial is actually, can anybody tell me now what is a binomial? One which has two terms. Okay, so tell me, what is a term? When you have an algebraic expression like ax square b y z, right, this will be said to be a term because this does not have a separator, a plus sign or a minus sign in between, right? So whenever there is a plus sign or a minus sign, which are the separators in between, right, then we have more than one terms, right? So plus and minus sign are the separators, and as there are no separators in between, thus you will say that this is having just one term, or is a term, or you can even say that this is a monomial. Now these are binomials as we have two terms here, as we have one separator, a plus sign in between, right? Obviously in place of the plus sign we can even have the other separator, which is minus sign, and even then it will be said to be a binomial. Okay, for common binomial expansions like a plus 2, a plus b whole square, we have the value, we know it, right? You've been learning it in algebraic identities since class 8, I think. Now if you talk about a plus b whole cube, again that is a value that you know clearly, and you even have its values if they are changed a little, like a minus b whole cube and so on. But if you ask some crude value of n for which you have to write a binomial expansion, so I think you will also have to start thinking crudely. So in place of you thinking some, say, crude technique, trick, or probably some strategy to be able to get to it, rather there is a theorem which generally tells you that if you have a positive integer, then what will be the expansion of a binomial. So that, children, is what we've discussed here. That is, if we talk about x plus a raised to the power n, then that becomes equal to nc0. Now do remember here, children, that this is the binomial coefficient, right? As you know that coefficient is a number, so this is a number which is associated with the first term, right? And as it is there in the binomial theorem, so it's a binomial coefficient. Now we will just now be discussing about what the binomial coefficient is. Now this is multiplied with x the first term raised to the power difference of the numbers in the superfix and the suffix times of the second term a raised to the power number in the suffix. So this number is the number in the superfix, this is the number which is there in the suffix. I'm sure when it is written like this, you must have seen it in chemistry when we talk about nuclear physics, right? On top we have the mass number, and at the bottom you have the atomic number, remember? Okay, now here, children, if we talk about the second term, this is going to proceed further. That is, after nc0 you will now be having nc1, right? So one thing which is very important for you to remember is, if you talk about the first term, the binomial coefficient actually starts from 0, right? So this is something that is very significant, and you require to remember that the first binomial coefficient is nc0, and obviously with the help of that you will be able to find out what the powers of the first term and the second term are going to be. Now next, children, if we talk about the second term, after nc0 the binomial coefficient will be nc1, and then the power of the first term x is going to be again the difference of the number in the superfix and the suffix, that is n minus 1, times of a the second term raised to the power number in the suffix, that is 1. And then Without looking here, I'm sure you'll be able to tell that the third term is going to be NC2 after NC1. Remember, x, which is the first term, raised to the power difference of the numbers in the superfix and the suffix, that is n minus 2, times of a, which is the second term raised to the power number in the suffix, that is 2. Right, so this is how all the terms of the binomial are going to continue, and the last term is going to be NCN, x, the first term raised to the power difference of the numbers in the superfix and the suffix, that is 0, times of a raised to the power number in the suffix, that is n. Now children, here we get to see that if we talk about the expansion, in between there is a term which is generally known as the general term, with the help of which we can find out any nth term like the 10th term, 12th term, etc. So the general term is written like NCR x raised to the power n minus r times of a raised to the power r. So here we are talking about the binomial coefficient to be NCR, and obviously the first term will be raised to the power the difference of the numbers in the superfix and the suffix, that is n minus r, times of the second term a raised to the power number in the suffix, that is r. Now children, can anybody tell me how are we going to write the general term? I know that this is a crude question, as I've already told you what the general term is, but I'd like to know how will you write the general term. I'll give you a few seconds. Right, your time's up. I'll tell you. If you talk about the general term, this obviously can be written as TR plus 1. Now there is something which is very special that I want to outline here. That is, when you talk about the first term, then obviously that's this. And in that you get to see that the binomial coefficient is NC0. Right? If you talk about the second term, then you get to see that the binomial coefficient is NC1. Now if you talk about the third term, then you get to see that the binomial coefficient is NC2. Thus, whatever term you're finding out, then in writing the binomial coefficient in the suffix, you will write a number which is 1 less. So here when we are talking about NCR to be the binomial coefficient, so obviously the term should be r plus 1th term. So remember, the r plus 1th term will be NCR x raised to the power difference of the numbers in the superfix and the suffix, that is n minus r, times of a, which is the second term raised to the power number in the suffix, that is r. Right? So this is how we find out the different terms of a binomial theorem, specifically required when you talk about the number in the index to be pretty crude, like 13, 23 or whatever. Right? So now children, with the knowledge of this, we will now be discussing a few sums. Now like I told you, at the moment there is going to be a humorous session, so let's have it. And after that obviously there will be a sum that I'll discuss, right? And then I will be giving you more sums, right, which you can access if you click on the link which is there in the description, right? Or you will even find it out in the first comment, right? So when you click to it, you will get the other exclusive content that I have for you people, which is concerning the binomial theorem. Okay, now children, let's get to this. So when we talk about Finland, we are talking about, say, Finland to be a land of 1,000 lakes. I'm sure you must have learned this, and you must have learned this in general knowledge. Yes, I'm sure there must be some children who must have participated in some general knowledge quizzes, etc., some competitions, and obviously you are awarded a prize if you say this, that Finland is actually a land of 1,000 lakes. But I'm going to negate this, as I'm going to give you a different number. 1,87,888 is the documented number of lakes which Finland has. I'm sure you're getting to see here that this is a phenomenal number, right? So this many lakes are there in Finland. And this lake land that we just looked up, this is the largest lake land in the whole of Europe. And actually there is 25% of lake and its water, and rest 75% is land, which is actually lined up between this lake water, which has been formed from the ice ages, right? It was some 10,000 years back. So when the ice melted, they formed these lakes, and then we have these pieces of land in between. And you'll be astonished to know that there are actually cities which are based in this lake district. So these small pieces of land might be looking to be very small, but there are certain big pieces of land also, which is known as isthmuses or peninsula, where they're actually cities, right? Okay, so this is a very nice place. I'm sure you'll really like it. But you know what? That it is normally said that why go to Finland? Because there's nothing to do. This is what a person from Europe said. So I asked him why. So he said that because it's all dark, forests, lakes, right? And there's no sun sometimes. So I said, why? That's because if you talk about Finland, it has one of the cleanest air qualities. It's got billions of hectares of forests. There are lakes which have so fresh and pure water that you can have it directly. In fact, the people from Finland have water directly from their taps. They don't filter it, right? Now, there's another joke about Finland. It is normally said that if you talk about Finland, sometimes say if you ask what time will the night be, then they are not going to tell you some hours. They are going to tell you some days. That is because sometimes what happens is the days continue for 73 consecutive days. That means the sun doesn't go down. And if you talk about the nights, sometimes the nights are so long that the sun comes after 51 days, right? So these are polar days or polar nights, right? Which is another speciality of Finland. Obviously, there's more which I'm going to discuss in times to come. Well, at the time, I'm going to discuss now here a sum which I have kept exclusively for you people, and that is this. So quickly give it a try. I'll give you people a little time for trial, and after which we'll be discussing the sum. And remember, there are more interesting facts about Finland which I'm going to discuss, and there's still the sweet delicacy. How many children like sweets? Right, even I am a big fan of sweets, and that is one of the reasons why sometimes I really have a lot of weight. That is because sweets have a lot of calories. Okay, now children, have you tried out the sum? If you haven't, as I know that most of you people are online, so what you can do is at the moment you can look it up, and you will get other chances where I will throw sums towards you and you can do it, which are of this type. Okay, at the moment, let us quickly discuss what this sum is. Now children, if you talk about this sum, here you get to see that we have an expression which is 2 raised to the power 3n, from which 7n is subtracted, from which further 1 is also subtracted, right? Now what I'd like you people to do is quickly take out from this 2 raised to the power 3n, and further from that take out this 2 raised to the power 3, right? And what is 2 raised to the power 3? Obviously that becomes 2 into 2 into 2. So as 2 into 2 is 4, into 2 will become equal to 8, and thus what am I asking you to do is I'm asking you to take 8 outside. Okay, done. Let's take 8 outside. Now what do we do next? Now if we talk about this 8, obviously again it can be written as 2 raised to the power 3, right? I'm sure you people must be thinking that what the hell is happening here, right? So this 2 raised to the power 3 which has been taken is actually 8, and if you want to write this 8, we know that we can write that as 1 plus 7, right? Because 1 plus 7 is going to give us 8. Now I'm sure you people must be wondering, why is it that sir has used 7? So can you reason? Yes, Mariam, you are correct. That is because here we are trying to talk about 49, and if you try and think, 49 is actually the square of 7. So we're trying to get ourselves directed somehow which is close to something which is related with 7, right? As such, here children, what we do is now we write this 8 to be actually equal to 1 plus 7, and if we talk about this 8 raised to the power n, that will be equal to 2 raised to the power n, and thus it can be written to be 1 plus 7 raised to the power n, right? So remember, I asked you people, let's quickly be directed towards 2 raised to the power 3n. So as such, here, as there's a rule of indices which tells you a raised to the power m when raised to the power n gives you a raised to the power m into n, right, which is the power of power rule in exponents. Many people will not be knowing the name of this. This is the special name of this rule in exponents. So obviously here also you get to see that you have here 2 raised to the power 3, which is raised to the power n. So obviously this is going to become 2 raised to the power 3n, right? And that is what we've written here. So we have this to be 1 plus 7 raised to the power n, and now children, it becomes a binomial. So you will quickly be reminded that if you have some x plus a which is raised to the power n, then that becomes equal to nc0 x raised to the power n minus 0 times of a raised to the power 0 plus nc1 x raised to the power n minus 1 a raised to the power 1 plus nc2 x raised to the power n minus 2 a square, and all of that continues up to n terms where ncn x raised to the power 0 a raised to the power n is actually the last term. So now children, here when we talk about this binomial theorem, there is still one thing which is left to know, that is the binomial coefficient. So let us now talk about the binomial coefficient. So when you have a binomial coefficient which say is something like NCR, right? So in this then, as this is going to come out to be a positive integer, I'm going to show you how. Now when we have this NCR, this actually becomes equal to factorial of n, that is the number which is there in the superfix, divided by factorial of n minus r, and that is further multiplied by factorial of r, right? So this is what a binomial coefficient is, and here children, I will quickly give you an example. For that matter, let us say now we have 10 C8 which has to be found out. So this will become equal to, you will tell with me because you already have it, just put up the numbers. It will be factorial 10 divided by factorial of 10 minus 8, which is further to be multiplied with factorial 8, and this children is going to give you the integer which this binomial coefficient is referring. Now why did I say that this is going to be a integer? That is because everything is going to get so cancelled that in the denominator you will just be left out with one number. Can you tell me what that number is going to be? No, that will be 1, because I told you this is going to become an integer, right? Okay, so if we try and further calculate this, just let's look it up. I'm sure you'll be able to understand more when I calculate this. So here children, we can further write this as 10 to 9 into factorial 8, right? Because factorial 8 is what? Factorial 8 is equal to 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. I'm sure nobody has a problem in this because you're getting to see that that is just the numbers in reverse order from 8 to 1, right? When all of these are multiplied together, this is known as the factorial of 8, and similar is the case when you find out the factorial of any other number. Now in the denominator children, we have 10 minus 8 factorial, which is factorial of 2 times of factorial of 8. So we get to see that factorial 8 will get cancelled with the factorial 8 which is there in the numerator, and then further we have 10 into 9 which is to be divided by 2 into 1, which is just the same as 2. So 2 5s is 10, and as such 45 will become this binomial coefficient which is 10C8, right? So as you've seen here, this has come to be an integer, rather a positive integer. So whenever you calculate a binomial coefficient, you will always get to see that it comes out to be a positive integer. Now children, let's get back to what sum we were discussing. We had 1 plus 7 raised to the power n which had to be expanded. So let's get to that. So if say we now talk about 1 plus 7 which is raised to the power n which has to be calculated, so obviously you can write this to be nc0 1 raised to the power n times of 7 raised to the power 0, to which is to be added nc1 1 raised to the power n minus 1 times of 7 raised to the power 1, and then you have nc2, right? That is, after 1 you have 2, right? Times of 1, which is the first term, raised to the power difference of the numbers in the superfix and the suffix, that is n minus 2, times of the second term, 7 raised to the power number in the suffix, that is 2. And children, all of that is going to continue up to the last term, right? So what is one special thing that you've got here? Rather, I'll write one more term, and that'll help you in prompting that what I am asking. I'm asking you, what is the special thing that we have got from here that we've just written? Yes, Mariam, can you tell me? No? Well, I'll tell you. If you talk about these terms in the binomial expansion of 1 plus 7 raised to the power n, obviously the last term is going to be n 1 raised to the power 0 and 7 raised to the power n. But specifically, if we talk about the terms which start from here up to here, we get one special thing. And what is that? Very correct. That is actually this 7 square, which actually is going to give you 49, right? And as all of these are actually a product of 7 square with some other number, like this 7 cube can be written as 7 square, which is multiplied with 7. This 7 raised to the power n can be written as 7 raised to the power 2, which is multiplied with 7 raised to the power n minus 2. Again, here a rule of indices gets applied. That is, if you talk about a raised to the power m, which gets multiplied with a raised to the power n, then that becomes equal to a raised to the power m plus n, right? So if you have the product of 7 raised to the power 2 and 7 raised to the power n minus 2, you will have had this 7 square. So if you talk about this third term, right? So third term onwards, we are always getting a 7 square, right? So as such, this is a speciality, and thus these terms can be segregated, can be kept on one side of the equation with 7 square to be taken outside. As such, it can be said to be divisible by 7 square or 49, as when it will be divided by 49, then this 7 square will get cancelled. As such, there will be no remainder which will be left out. Okay, so now let's talk about the rest of the things that we have. So on the left hand side, children, we have 1 plus 7, which is raised to the power n, right? And then we have the term on the right hand side, which is nc0. Now let's try and calculate this. So if you talk about nc0, children, then that will become equal to n factorial divided by n minus 0 factorial times of 0 factorial. So that will then become equal to factorial n divided by factorial n times of, do remember this, a very important entirety, that is, whenever you talk about factorial 0, then that is equal to 1, right? And another important thing is, whenever you have the factorial of a negative number, then that is always 0. So if you talk about factorial of, say, minus 7, or if you talk about the factorial of minus 16, all of these are equal to 0. So the factorial of a negative integer is always equal to 0. Now, can anybody tell me what does this show? Yes, Mariam. What is it that this shows? That the negative of a positive integer, when its factorial is found out, it is 0. I'll tell you. If you talk about any binomial coefficient, then something like 8c17 is what is going to give you this, because when you write in the denominator n minus r, so that will become equal to 8 minus 17. And don't you think that this is a negative number, right? And as this is a negative number, when you find out its square root, its factorial, it will come out to be 0, and as such it is going to become undefined, right? And that is the reason, children, that we talk about such binomial coefficients, where when you want to find out the binomial expansion, then the value of n, that is the number in the superfix, should always be larger than the number in the suffix, right? So here children, now next we move towards 1 plus 7 raised to the power n and further try and write the value of this. We just now got the value of this, that is factorial n upon factorial n, and that children is going to give us just 1, as both of these are going to get cancelled. Now next children, if we talk about the value of the next binomial coefficient, that is say nc1, now let's see what it comes to. It's going to come to be factorial n divided by n minus 1 factorial times of 1 factorial. Now if we further talk about this, here children, we can write this as factorial n times of factorial of n minus 1, as if say you multiply 1 into 2 into 3, right, with a number which is 4, right, you will get this to be factorial 4. And as you know that if you talk about the first 3, it is actually factorial 3. So if factorial 3 is multiplied with 4, it's going to give you factorial 4. And thus, if you multiply n with factorial of n minus 1, it is going to give you factorial n, right? And this is why we write it so. And in the denominator children, we have factorial of n minus 1, so both of these cancels, and in the denominator you are left out with 1. As such, nc1 comes out to be n, right? Next now children, after this what we have is we have nc2, which is another binomial coefficient which has to be calculated, and that then is going to become equal to n factorial divided by n minus 2 factorial times of factorial 2. And this is something that we need not worry about. Why? Can you tell me? Well, I'll tell you when I'm going to write further. So here now children, we get to see that from the third term onwards, when we get nc2, we already have 7 square. As such, we need not expand this, as only 7 square can be kept outside and rest of the terms inside, and then we will be able to show the divisibility of 49, right? And thus we don't require to calculate it, right, as we already have 49 outside. So automatically that means that if any number is such that it divides this number so that there is no remainder, then it will be the multiple of that number. Like in this case we have 49, so if 49 is in the denominator, it will divide 49. As such, whatever is inside, that doesn't matter. We will just see it just now. So when we talk about the first binomial coefficient, it came out to be 1. Now that is going to be multiplied with 1 raised to the power n, and 1 raised to any positive index will always give you 1. And further, 7 raised to the power 0 is also 1. So there are 3 ones together, right? And to this now is added nc1, which we just calculated to n, right? Remember, we got this n here, and to this is going to be multiplied further 1 raised to the power n minus 1. Again, this is going to become equal to 1, because 1 raised to any power always becomes 1, and then further it is multiplied with 7. So as such, this is going to give you 1 plus 7n. And if you talk about the terms which come after this, we find that we can take this 7 square to be common outside, and inside then we'll be left out with nc2, right? Again, 1 raised to any power will be 1, so as such, 1 being multiplicative identity, we can neglect it, and then we will now have nc3, again 1 raised to any power will remain to be 1. As such, 1 being multiplicative identity can be forgotten, and thus here, as 7 square has already gone outside, so 1 7 will be left out, and all of this children is going to continue up to the nth term, right, which is going to be ncn, right, times of again 1 raised to any power, that is 0 will also be 1, 1 being multiplicative identity will vanish, times of 7 raised to the power n minus 2, as 2 powers of 7 have already gone outside. So next children, now we get to see that these two terms, right, can be taken over to the left hand side, because these are the ones who are spoiling the party of this side to be a multiple of 7 square, that is 49. And then we can talk about now 1 plus 7, which becomes equal to 8 raised to the power n, from which if we subtract 1 into 1 into 1, which is 1, and we subtract n into 1 into 7, which is 7n, then on the other side we will actually have 7 square, which is multiplied with any, say, natural number, and we can name it to be, say, some capital N, because the binomial coefficients will come to be natural numbers, and when they are multiplied with some of the other powers of natural numbers, they will also come out to be natural numbers, and when all of these natural numbers are added, it will also become a natural number, and that can be represented by this capital N. So here, as such, you get to see that what you require to prove has been proved, as you require to prove that 2 raised to the power 3n. So again, this 8 raised to the power n can obviously be written as 2 raised to the power n, 2 raised to the power 3n as we saw it, and from that if we subtract 1, or rather first let's subtract 7n, and from that if we further subtract 1, then we find that this is going to be a multiple of 49, as this is 7 square multiplied with n, that is 49n, right? Here you can say that for every n is an element of, again, positive integers, or you can even write in capital N, that is the set of natural numbers. Now children, here we get to see that by binomial theorem we've been able to prove that the expression on the left hand side is actually a multiple of 49. So all of this, children, I will just quickly discuss again. Here children, in the question you've been given that you have here an expression which is 2 raised to the power 3n minus 7n minus 1, and it is to be shown to be divisible by 49. So what you do is you take this 2 raised to the power 3n, which is the first term, and then you try and dissect it. From this you take 2 raised to the power 3, and obviously it can be written as 2 into 2 into 2, and that becomes equal to 8. And if you talk about 8, 8 is actually 1 plus 7. So this 8 raised to the power n can actually be written as 1 plus 7 raised to the power n, right? And now children, if we quickly be reminded of the binomial theorem, we know that x plus a raised to the power n will be nc0, x raised to the power difference of the numbers in the superfix and the suffix, that is n, times of a raised to the power number in the suffix, that is 0, then nc1 times of x, the first term, raised to the power difference of the numbers in the superfix and the suffix, that is n minus 1, times of a, the second term, raised to the power number in the suffix, and all of that continues up to n terms, right? Now children, if we talk about, for this case, 1 plus 7 raised to the power n, again here we can find out the expansion, but before that, one thing which was left over is going to be discussed here, that is, what is a binomial coefficient? For that matter, the definition is, binomial coefficient is a number which is multiplied with a specific term of the binomial expansion. Now here, if you talk about the binomial coefficient to be, say, some NCR, which if you remember we got as the general term, right? Excuse me. So do remember that we had the general term to be TR plus 1, which was NCR, right? So NCR is actually the binomial coefficient here, right? And this binomial coefficient can be calculated as factorial n divided by factorial of n minus r times of factorial r. So if you have some 10c8, then that can be written as factorial 10 divided by factorial of 10 minus 8 times of factorial 8. That is, this is the factorial of the number in the superfix divided by the factorial of the difference of the numbers in the superfix and the suffix times of factorial of the number which is there in the suffix, right? So further to calculate this as a simple number, what do we do is we now talk about this factorial 10 to be written in terms of the number of the larger factorial. For that matter, do remember that when we talk about factorial 8, it is actually 8 multiplied with a number which is just less, that is 7, further multiplied with a number which is just 1 less, that is 6, and so on till the time we get to 1. And the product of all of these numbers is the factorial of 8, and sometimes children this is also written like this. That is, after 8 we have an exclamation mark. So now children, when we talk about this factorial 10, we can write it as 10 into 9 into factorial 8, and factorial 8 and factorial 8 will get cancelled. As such, you'll be left out with 10 into 9 divided by factorial 2, which is actually 2 into 1. Now 2 cancels 10 5 times, and 5 into 9 is 45, and that, children, will become the value of 10c8. In a similar way, you will always see that whenever you calculate a binomial coefficient, it will always come out to be from the set of natural numbers, or you can say from the set of positive integers, right? Now children, in this case, when we further talk about the expansion of 1 plus 7 raised to the power n, we get to nc0, the first term 1 raised to the power difference of the numbers in the superfix and the suffix, that is n, times of the second number 7 raised to the power number in the suffix, that is 0, plus nc1, 1 the first term raised to the power difference of the numbers in the superfix and the suffix, that is n minus 1, times of 7 the second term raised to the power difference of the numbers in the superfix and the suffix, the number which is there in the suffix only, that is 1, plus then again the same thing, that is nc2, the third term, times of 1 the first term raised to the power difference of the numbers in the superfix and the suffix, times of the second term 7 raised to the power the number in the suffix, and all that continues. From here it starts losing significance, as we have got to 7 square, which is 49. Similarly, in the next term we get to 7 raised to the power 3, which can be written as 7 square into 7. Again we've been able to get to 49, right? And thus all the later terms will surely have 49, and thus what we can do is, from the third term onwards, we can take the 7 square to be common outside, and then we can write the rest of the terms, as any power of 1 will always be 1, and 1 is multiplicative identity. For that matter, if you talk about, say, some 181, you know that it means that 181 is multiplied with 1, right? That is because 1 is multiplicative identity, or in other words, in multiplication it is omnipresent. Now next, children, what you do is we further write the rest of the terms as they have to be. So here, as 7 square has been taken outside, so nothing inside, that is just 1, plus we have nc3 times of 1, which again vanishes, being multiplicative identity, further to be multiplied with 7, as 2 powers of 7 have already gone outside, right? And so on. This can be written for the last term as it is going to be 7 raised to the power n, that is the second term raised to the power number in the suffix, but as 7 square has already been taken outside, so 7 raised to the power n minus 2 is what's going to remain, right? Now children, these terms which do not have 7 square or 49 can now be taken over to the left hand side, and as such we will have 8 raised to the power n minus 1, right, from the first term, minus 7n, which will actually become equal to 7 square, which is multiplied with a positive integer or with a number from the set of natural numbers. Now that is because each of the binomial coefficients will always come to be from the set of natural numbers, and when they are multiplied with natural numbers, again the products will be natural numbers, and when natural numbers are added, that also gives you a natural number, and as such we can say that this number, which the sum of all of these numbers comes to, is actually a natural number, right? And for that matter, we can just change this a little. In place of writing this to be capital N, we can take it to be, say, some other number. Let's take it to be m, because capital N actually represents the set of natural numbers, right? So as such, what we can do here is we can take this to be, say, some capital M, right? And here too, thus what you'll do is you'll write this to be, say, some 49 times of capital M, and further you can again say that this actually is either from the set of positive integers, or you can even say that it is from the set of natural numbers, right? Because positive integers are like 1, 2, 3 and so on, and natural numbers are also like 1, 2, 3 and so on, right? So this is all about the sum that had to be done. As you see that here on the right hand side, you have 49, which is multiplied by a number which is from the set of natural numbers. As such, when this number is divided by 49, so obviously 49 will cancel 49 and there will be no remainder left out, and that is the reason you can say that this expression is going to be a multiple of 49, and this is what, children, we've done. So in the question you'd been asked to prove this, that we have 2 raised to the power 3n, from which is subtracted 7n, and from which is further subtracted 1, is to be proved to be divisible by 49, and we've been able to successfully show that this actually is divisible by 49. So is all of this clear? Sure? Did you like this? I'm sure you people enjoy lectures, especially if they cost nothing. So I have a series waiting for you people, right? So make sure you people do get to the link which is there in the description just at the beginning, or it is there in the first comment, right? So click on it and get to the space where I have given you more lectures so that you can understand more about binomial theorem. So children, do tell me how you like this lecture, and I'm sure by now, which is approximately 50 minutes up to which we've studied, I'm sure you people must be really hungry. So let's quickly get back to Finland, right? So first I'll give you a sweet delicacy of Finland, and then I'll tell you a joke. So while munching on that sweet delicacy, you can also keep smiling or probably laughing. Okay, so this sweet delicacy is known as munki. Munki, yeah, it's a very famous sweet delicacy, right? So have it, start having it, right? And do enjoy a joke with me. Now what happened was, there was a lady from France who actually, was interviewing some people for some position in a bank. So she came across people from different nationalities, because Europe, doesn't have any borders, right? So she came across this lady from Finland, and she was asked, from which country are you? From where do you come? She said, I come from a country, right, which is say that place which is just the end. So can you imagine? So that lady was startled. I am asking you, you come for an interview, I'm asking you a question, and you are answering that to me in a riddle. Well, she asked the question again with a smile. She said, just try. Okay, so she thought a little and wasn't able to answer. She said that I come from Finnish. So again, she was very angered, and she asked her, are you having fun in this interview? Now, are you trying to show that I'm a fool? You say that you're coming from Finnish, that means you're saying that you are actually coming from the death? She said, no, I am Finnish. So she said that you want to say that you are death, or you are just nothing? Then she gave the answer. Actually, ma'am, I come from a country which is known as Finland, whose citizens are known as Finnish. So this is that simple sweet joke. I'm sure all of this you must have enjoyed with this munki that I gave you, right? That was a real lovely sweet delicacy. And you also enjoyed all of this that we did in binomial theorem. And you're also going to click on that link which is there in the description at the beginning, or probably the link which is there in the first comment, right? And do write what all you learned in this, right? And if possible, do share with me in my email ID this sum done all over again. Do find out a sum from your book which is of the same type, do it and mail it to me so that I can check it and give it back to you. So make sure you enjoy maths, enjoy life, and do study maths, right? Make your maths strong.